Okay, so what we're going to do today is to pick back up with something that we talked about a little while ago. And so that is building towards demand curves. So, demand curves are these ideas that we saw a lot of in principles in micro. And so what we're going to be doing is to talk about some curves that are sort of similar to demand curves. And eventually we'll actually talk about demand curves themselves. And so the idea behind all of this is just that in earlier classes, like in principles, we would just sort of say, hey, the demand curve looks like this. Here it is. And so what we've been doing in our class is sort of starting from an earlier point of saying a person has preferences. For example, this person thinks that an apple is twice as good as a banana. And then you can move towards, sort of showing those kinds of preferences and showing the kinds of bundles that a person would buy um, by using something like a demand curve or by using some other kinds of curves, which we looked at briefly before the first midterm, and then we'll pick back up with that right now. Okay, so we're going to focus on graphically representing the bundle that somebody would buy. And so we looked first at the income offer curve. And so in income offer curve just means fix some PA and PB. So you just fix some prices and those will stay fixed as you draw your income offer curve. And then you're going to allow M, your income, to vary. It's going to start all the way at 0 and go all the way up to some very large number. And then what we do is just plot the different bundles that the person would consume along the way. So, basically one way to think about it is what would you buy if you were extremely poor? What would you buy if you were extremely rich? And, everything in between. So that's sort of what you're showing when you show a income offer curve. Okay, so let's do this example. So let's suppose that J has a utility function of A plus 4B, and the prices of both goods are 1. So what this means is just to say, for this person, having another apple, that will always give 1 utility. Having another banana, that will always give 4 utility. Right? So notice, by the way, that in a lot of our more complicated problems, the way that a person feels about apples and bananas, well, it depends on how many they have of each already, right? So, one thing that we see commonly is, well, I've already got a lot of apples, so I'd like to have some bananas. Well, this person doesn't have any of that. They just have apple gives me 1 utility, banana gives me 4 utilities, and it doesn't matter if, what is the currently existing bundle that the person has. Okay, so let's keep on moving. So the question is going to be, what is her income offer curve? And let me try to pitch the method that I use. And this is a extremely overarching strategy, but the strategy that I would always try to use is to just do some simpler version of the problem. Just break off like a little piece. If you need to, change the problem a little bit to make it easier, see how that works, and then expand back out to the bigger problem. Okay, so we're not going to try to do it all at once. So a mistake that I think some people would make is just to start like drawing your income offer curve. It's like, no, that's too soon. And it's important to go like in steps. So what we're interested in doing is plotting the optimal bundle for all of the possible different values of M, 1, 2, 3, fractions, huge numbers, small numbers, sort of a lot of stuff to deal with all at once. And so the way that I would try to simplify life is to say, well, let's just see what happens when you have an M of 3. So let's just figure out one particular M, and then we'll deal with everything else. Right, but so right now let's just focus on M equals 3. And so ordinarily I would like to do this in small groups. Obviously we don't have small groups because this is an asynchronous video lecture. If you happen to have a small group accessible to you somehow, great. If you're friends with someone in the class and you want to sort of do this at the same time, that's great. It's not necessary. Don't sweat it if you don't have that. I would expect almost no one does. So typically in class we would do this in small groups. I actually think that there's a fair amount of value as well in doing this individually. Right? I think that it's good to sometimes work in small groups, sometimes work on your own. And so this will just sort of be a on your own kind of day. The one thing I'll just mention is that, of course, everything is more challenging on your own, right? So if you're in a group of 3 or 4, you got a lot of different ideas going. So I guess I would like you to try these problems on your own, but don't get discouraged if you find them to be a little bit more challenging than problems sort of typically feel in class. Okay, so I'm not actually going to pause myself, but you can pause the video and take a minute, 2 minutes, and try to focus on what this person would buy when m is equal to 3. Okay, so hopefully you've done that. You've paused. You've now unpaused. And now I'm going to move on in the slides. Okay, so this is just repeating the problem. And so, one way I would look at this is let's just name some bundles that are feasible. These aren't all the bundles, but here are some bundles. You can get 3, 0 or 0, 3 or something in between. And then let's just figure out what utility you get for each of them. Well, you get 3, 0, then you get a utility of 3 times 1 plus 4 times 0, and so you get 3. And you can calculate the other bundles as well. The other extreme is the utility of 0, 3 is equal to, well, you get no utility from apples, 0 times 1, and then you get 12 utility from bananas, which is 4 times 3. And so you get a utility of 12. And you can see that the utility is the highest when you get a bundle like 0, 3. When you get, in fact, exactly 0, 3. So 0, 3 gives you a utility of 12, and that is, in fact, the highest possible amount of utility. Okay, so we've sort of glossed over the fact that fractions are allowed. Fractions are always allowed, and so you could do a bundle like 0.5 comma 2.5, but it should be clear, hopefully, based on this kind of calculation, that 0, 3 maximizes the utility. Every time you add a banana, you get 4. Every time you add an apple, you get 1. Okay, add all the apples. Excuse me, add all the bananas that you can, and each one of those will give you 4 utility. Okay, so that's what we have so far. So we can also say, well, we found with m is equal to 3, the optimal bundle is all b's. That's what we just did. But this is going to work for all values of m, right? Like if you're doing m equals 2 or m equals 20, you're going to have that same idea, right? It's like, why would I spend $1 on apples and get 1 utility when I could spend that same dollar on bananas and get 4 utility? So yeah, there's just not any reason to buy any apples in this problem. Right, so if we see that if m equals 0, then your optimal is 0, 1. If it's 2, then your optimal is 0, 2, and so on. And so what that means is when we plot all of the optimal bundles, we want to be plotting 0, 1, 0, 2, 0, 3, and so on. And just keep doing that, just all of those bundles. And by the way, we should also mention that this plot goes all the way back to 0, 0. Like based on what we've said so far, we've only been talking about going back to 0, 1 as sort of our starting point or our leftmost point. In fact, it does go back all the way to 0. One way to think about that is, well, if m is 0, then your optimal bundle is 0, 0. It's kind of funny to think about that as an optimal bundle when it's literally the only thing you can consume. But you can also say that if m is 0.01, then the optimal bundle is 0, comma 0.01. And so just the idea here is that we want to make sure that we go um, all the way to the origin with our line. By the way, I think I said leftmost point before. I should have said lowermost point because we are sort of going along the vertical axis. So we want to be thinking about so we're thinking about the sort of low points down near 0, 0 rather than like the leftmost points. Okay, so I am going to pause the video there. We'll take a break and come back in the second part of the video just to give you all a chance to take a little break as well. And so I will stop the video here and I will see you again in just a moment.